first one. What do people get? Step out on a limb. Tell me what you got. It's okay to make a mistake. What you got? Negative 6 over pi. Okay? Two. Okay. 2 pi over 3. Okay. All right. So let's think about this one. What is the sign at 7 pi over 6? Negative half, right? So this really, I'm looking for when the secant is equal to negative 1/2. Okay? So if I'm looking at my secant graph, which we had from Monday, I'm looking where on that graph I hit negative 1/2. Do I ever hit negative 1/2? No, because negative 1/2 is right here. Right? It's all through there. Oh, now it's zooming in on me. Okay? All through there. Never hit negative 1/2, right? So, can I find where the inverse secant is negative 1/2? No. Secant has to be greater than 1 or less than negative 1. Okay? Because think about it, secant is the reciprocal of cosine, and cosine has to be between negative 1 and positive 1. Right? Okay? So the reciprocal then, if I take 1/2 and I reciprocate it, that's 2. If I take the square root of 3 over 2 and I reciprocate it, that's 2 divided by the square root of 3, which is something like 1.7, something, I don't even remember what it is. Okay? Alright? On this one, no. Because it's the secant. Just like it's kind of a logic thing. You know what I mean? You got to know that secant has to be bigger than 1, smaller than negative 1. You also got to know that cosine and sine have to be less than 1, bigger than negative 1. Okay? So it's got to fit in that acceptable range. Okay? So this one here is undefined or not possible. I also accept there too. Okay? Right? That one was our trick question of the day. Okay? So now let's get back into what we were doing yesterday. Alright? So cosecant of the inverse tangent of negative 5/12. I almost said negative 5/2 there. Negative 5/12. Which quadrant am I in? Is my triangle in? Because now I'm going to do triangles. Which quadrant is my triangle in? No. Quadrant 2? Okay. So my triangle is in quadrant number 2? Quadrant number 4. Right? Because tangent is only right half of the circle. So I'd be in quadrant number 4. Okay. Okay. So then my theta would be here. Oops, that's a bad theta. Oops, now it's making it even worse. There. Okay? So tangent tells me that's opposite, right? Over adjacent, TOA. So that means that this side over here is my -5. That side up there is 12, which means my hypotenuse then is 13. Okay? So really here I am looking for the cosecant of theta, which is 1 over the sine of theta, which is 1 over the sine of theta would be 5/13, right? But because I'm in quadrant 4, it's -5/13. The reciprocal of that then is -13/5. Agree with that? Okay. Try those two. Arctangent is positive in quadrant number 1. It tells me then that my opposite side is 3, my adjacent side is 5, which means my missing side is what? Square root of 34. Because I've got 3 squared plus 5 squared equals c squared. So that's 9 plus 25. So that's 34 equals c squared. So this is the square root of, that should be a 4 in there. That's much better, 34. Okay. So this is telling me that I want to find the cosine of theta, which is my opposite side, my adjacent side, 5 over the square root of 34, or I could rationalize that denominator and make it look like that. Okay. Cotangent of the arctangent of 1/3. Arctangent is positive in quadrant number 1. Opposite side is 1. Adjacent side is 3. 1 squared plus 3 squared is c squared. That's the square root of 10. Okay? So this is basically asking me for the cotangent of theta, which is 1 over the tangent of theta, which is 1 over 1/3, which is 3. Could have also went to cotangent being instead of TOA, it's AO, adjacent over opposite. Okay. Alright, let's try this one now. Okay? Only thing that tweaked is, instead of giving you a fraction, I'm giving you an algebraic statement. Okay? An algebraic expression. Okay? The nice part about 9 out of 10 of these algebraic solution type 1s is that they're going to be in quadrant number 1 because they're going to have a positive number in there. So we set them up the exact same way. What this really means is this is the sine of the arc cosine of, let's put it in fraction form, of 3x over 1. So now my adjacent side, because I'm dealing with cosine, is 3x, and my hypotenuse is 1, because I'm dealing with cosine. So this really is, I'm looking here for the sine of theta. Sine of theta is going to be my opposite side, which I don't have yet, so we should find that using the Pythagorean theorem. Let's call this b. So that's going to be 1 squared is equal to the quantity 3x squared plus b squared. So that's 1 equals 3x quantity squared. 3x quantity squared. 3x times 3x. 9x squared. Subtract 9x squared. Take the square root. Now, very important mathematical type question. Can I simplify the square root of the quantity 1 minus 9x squared? Meaning this bad boy down here. Can I simplify that? Yay or nay? Thumbs up, thumbs down. Or middle if you don't know. A lot of thumbs down, which is good. Okay, why can't I? Because there's an addition or a subtraction sign. Yep. And if there's an addition or a subtraction sign, that whole expression has to be a perfect square. It's factorable, but it factors to be 1 minus 3x and 1 plus 3x. Not the same thing. So that's how it stays. So b here is the square root of 1 minus 9x squared. So my sine then is going to be the opposite side, the square root of 1 minus 9x squared, over my hypotenuse, which is 1, which can just simply be written as the square root of 1 minus 9x squared. Okay? Try cosine of the arc sine of 2x. Set it up in quadrant 1. Here's my theta. Sine is opposite over hypotenuse, so I could really put this over 1. Okay. Okay. So I need to find that missing side. So 1 squared equals 2x quantity squared plus b squared. Call that side b. 1 equals 4x squared there plus b squared. Subtract 4x squared. square root so this really here is the cosine of theta. The cosine of theta is going to be the adjacent side, the square root of 1 minus 4x squared, all over the hypotenuse, but the hypotenuse is 1, so we're good to go there. Okay? Try those three. Finish this off. So, cosine, that is in quadrant number 1 because it's positive. Cosine is adjacent over hypotenuse, which gives me, if I do a 1 squared equals x squared plus b squared, that's going to give me 1 minus x squared is b squared. That's going to give me the square root of 1 minus x squared as b. Okay, so the secant here then of theta is going to be then so that's 1 over the cosine of theta. So that's 1 over the cosine of theta is going to be x over 1. So that's going to be 1 over x. Or we could have said secant is hypotenuse over adjacent, okay, because it's the reciprocal of cosine. Gotten right to it. Okay. Sine is opposite over hypotenuse. Well, that's the same math, it's just in a different spot. Okay? So this is going to be the square root of 1 minus x squared. Okay? So I really need here the tangent of theta, which is going to be the opposite over the adjacent. And because it's, I don't like how that's written. Oops, this one, that one. A little separation there. I like that a lot better. OCD. Okay? Because it's algebraic, we can just leave it like that. Cosine of the inverse tangent of x. Tangent is opposite over adjacent, so that's here now. So that changes, that tweaks my math just a little bit. So that's 1 plus x squared is equal to c squared. So that is a little too far. The square root of 1 plus x squared. Okay. So this is the cosine here of theta. Cosine of theta here is adjacent over hypotenuse. Okay? Again, of the two sheets that I handed out, the purple sheet, if we collect it, we will collect it on Friday of next week, which is the day of your test. The eyeball melting red worksheet is your formative assessment. That one is due in class on Monday. Okay?